Hello student, I hope everybody is fine and enjoying the good health. So today we will have this class on derivation of the equation of motion. So before we move into this topic, you should be very clear about the various terms that you have been told in the various video presented to you. So you just consider here uniformly accelerated motion, that is uniform accelerated motion along a straight line, and object cover a distance. The object is, consider an object covering a distance s during a time interval t. So, okay, covering a distance s during a time interval t. So, you can see in this particular graph of velocity time graph that we will use this to calculate the distance covered. We will calculate the distance covered. So, watch this video very carefully. Calculate the distance covered during the given time interval. So, this is the basically a simple illustration for this particular labeling of the graph, that body is having a uniformly accelerated motion that is being shown by the straight line in this particular figure. Okay. Now, these are the terms that you should be knowing about it. So, I hope you know what is letter u, small u. It illustrates initial velocity. So, write it down because we will be very clear about these abbreviations, okay, or these representations. And then you must also know what is v. So, v is final velocity. Write it down in your copy and textbook. Please keep them in your vicinity and use them as the tutorial proceed. Final velocity is v. Okay. And then, as you can see in the graph, we have the time and on the x axis and velocity on the y axis. So, it is a velocity time graph which we will use to derive the various equations of motion. Okay. Now, let us begin the various equations. So, I hope you should know these equations. So, number 1 equation of motion. So, v equals to u plus at, write it down side by side. Second is s equals to ut plus half at square, and third one is v square minus u square equals to 2as. Okay. So, we are going to read about these equations, how to derive them, and thereafter we will get into the right mode of solving the numericals. Okay. So, let us begin with the first derivation. So, graph is constant for all the three. So, make sure you should draw the graph very properly, and then you should be knowing about the data. So, here as I have told you, initial velocity is OA, final velocity in this figure is BD, and time is taken on the x axis. Okay. So, as we read about all these things one by one, you should be knowing about that. Now, how to derive it? So, as I have told you, this particular slope represents what? So, this represents the uniform acceleration of an object. So, it represents the uniform acceleration. Okay, write down this word uniform acceleration. You already should be knowing it when you have read about these definitions. Okay. So, this particular line, that slope we call it, represents the uniform acceleration, and by definition you know this uniform acceleration is given by, so A equals to change in velocity. So, write it down, change, okay, change in velocity. So, change in velocity over time. Okay. So acceleration is nothing but change in velocity over time. Now, if I say change in velocity, what do you mean by change in velocity? It means, of course, the final velocity minus initial velocity over time taken, that is the change in velocity. Now, in this graph, if I ask you what is V here, so you can see V is the complete B and D. Okay, so complete V and D, that is B and D is V, and OA is the initial velocity and OD is time. Okay, so you can also first write that A equals to complete BD minus OA over the time axis, that is the OD, and when you just change these position of these abbreviative letters, you will get the data that you are looking for. So, I can write this as V minus U equals to 80, and from that you can get the most needed formula looking for, that is V equals to U plus AT. So, this is nothing but the first equation of motion. Okay? First equation of motion. Now, after knowing it, again go through it the whole presentation to check out the actual format for solving it. So, I again repeat, this slope represents acceleration, and you know acceleration is nothing but change in velocity over time. So, change in velocity is what? This is the whole velocity BD and then OA. So, you can say BD minus OA. So, BD minus OA represents BD minus OA. Okay. So, that represents the change in velocity, and what is the time here? Time here is OD. Okay. So, write down at the base OD. So, now you should know BD is nothing but V, minus is here, OA is U, OA is U, write them properly, and OD is T. So, ultimately you get the equation and then you just solve it, replacing the values and get the answer. Okay. So, that is the first equation of the motion. Now, again for the second equation of the motion, now again check it out. The second equation I have told you is S equals to, okay, so S equals to UT plus half AT square, that we are going to derive now. So, again now check here. So, what does S stand for? So, S stand for the distance covered, okay, distance covered. So, distance covered in this graph is this whole area, okay, that is under this graph is called distance covered. Now, how to calculate that distance covered? So, in order to make it simplified, you can see if that is the whole distance, I can break it up into two parts, 1 and 2. So, this first part you can see is a rectangle and second part is a triangle. So, that gives you a good hint that how we can solve it. So, that means the distance covered in this graph is given by, so area of rectangle, plus area of triangle. Now, which one is rectangle and which one is triangle? That I hope you all know it. So, in case of area of rectangle, so we can call it the area of rectangle as the name you can give it. So, area of rectangle is said to be say OACD. Okay. and area of triangle is, please write it down side by side, otherwise you will just lose it. The area of triangle is, which is the area of triangle, or the triangle's name is A, B, C. You can see it from the diagram, A, B and C. So, these are the two figures we are looking for in order to solve the data or the equation. So, that means now I can say the distance covered is given by area of rectangle. So, what is area of rectangle? Length into breadth. So, I can write OA into OC. Okay. Check it out properly. OA into OC, or we can call it as from the diagram OA and OD, okay, from this diagram. And thereafter, what is the area of triangle comes to be? So, we know it is half into base. What is base? AC in this diagram, and altitude is BC. Okay. So, check out this number. So, these two formula is known to us. Now, just put the value in term of that and see what you will get it. So, in case of the triangle, so OA into OC will be, you can call it as, so area equals to U into T because OA is U, you can see, and OD is T. And for triangle half, what is the base here? Base is again AC. AC is nothing but equals to T only. So, we can say T. And what about the BC? So, in order to get BC, can I write the word for BC as AT? Check out properly. Can I say BC, this part is equals to T or equals to AT? You might say, sir, how it is possible? So, you can again say, so what is OA for us? OA is U, okay, and what is BD for us? Check out the whole term. So, BD is V. So, BD is V. So, what about BC? So, BC means V minus U, V minus U. So, you can write it there. BC can be written as V minus U. Now, V minus U. Now, this is been approximately can give you some idea that V minus U equals to AT. We have just done it in the first equation of motion. So, instead of writing V minus U, I can put the value of V minus U as AT, yes or no, and hence that term will become AT, okay, half base into altitude. So, BC can be called as AT. Now, just simplify the equation and you get your answer. So, here you can see half, take it half, then A and T into T. So, what is T into T? T square. So, if you solve the whole statement of this, so what you will get it? So, you will get UT plus half AT square. Okay. Now, combine them to get the second equation. So, second equation should be written down like that, S equals to UT plus half AT square. Okay. So, again pause the video, go through the whole data, and I hope the things will be easily understood by you, and this will help you out to understand it, that how we derive the whole equation, and also let you know that how to study this graph again and again. Okay. Now, let us move for the third equation of motion, which is what according to you? You should be knowing it because I have told you in the beginning of the topic. So we are now going to derive the relation v square minus u square equals to 2as. Okay, v square minus u square equals to 2as. Now again, now plan out how to derive it, because if you have understood the first two equations, the third is again very simple. Now you can see here again the whole distance traveled by the body. This is the whole shaded part. We call it distance traveled as s equals to what? Now here we just take a different type of observation. Now check out this figure, and if you have read this term last year, can you recollect that what type of figure it looks like? Well, it is close to a figure called trapezium. Okay. So now we will use this geometrical figure for our derivation. So trapezium. So in this case, I can say the area under this graph can be shown by the area of trapezium. Okay. So trapezium. So for us, the trapezium is O, A, B, C, D. Okay. So write down this term. The name of the trapezium is O, A, B, C, D. Now, if you remember that what is the area of trapezium? So, you know, area of trapezium is given by the formulae, and I hope you should know that particular formulae. And what is that? It is half into sum of the parallel sides. Okay, sum of the parallel sides into height. Okay, into height. Again, check it out. So it is half the sum of the parallel sides into height. Now, what are these sides which you can think to be parallel? So you can see this side is parallel to this one, and this will be the height of the trapezium. So just putting the terms in the respective order, you get the solution. So in this case, so write it down, half the sum of the parallel sides are what? So you can see, so OA plus you can call the whole BD, and height is nothing but OD. Okay. So into OD you can call it. So now put the value of this term, and you are approximately at the exact location of your derivation. So half will come like that, no problem, into, so sum of the parallel side I have told you. So what is parallel side? OA is U and V is the other side, into T. Okay, that you got it. Now again we will take the help of equation number 1. So what it was letting you know? So it says V equals to U plus AT. Now check out the stuff and on your own see what we can now think it of. Now we want to replace this T. Okay, so I can obtain the value of T from here. So what could be the value of T from here? Just think it of. What could be the value of T from here? So it is V minus U over A. Okay, is T. That is the thing that we are looking for. Now just place that particular value in place of T. Okay, so in place of T, I can write that value. And what was the value was? V minus U over A. Now it is simple mathematical relation that you can solve it. So what you do is now bring the denominator with 2. So it will become 1 by 2a, and in the bracket what you have? You have V plus U. You can write it for your understanding, V plus U and V minus U. Okay. v plus u and v minus u. Okay, this whole term like that. Now, what you can think of these two terms? You can see get you a good identity in the mathematical formula a plus b a minus b. So, now instead of this I can write the simple definition or the simple explanation about this term. So, it will become as half, that is just write 1 by 2a. So, v plus u and v minus u gives you in that term as v square minus u square. Okay. Now, combine the term. So, it will get that s equals to v square minus u square over 2a. Now, just transport the denominator on the other side and you get the result. The result is v square minus u square equals to 2as. Okay. Now, this is the equation number 3. So, as you have seen that the whole thing is being solved in a very simplified form. So, again go through the whole presentation and the tutorial and practice this question in your physics copy as well as in the practice session. So, that you should be clear about this data, because we are using these equation for our various equations of motion in a numerical solution. Okay. So, take care, have a nice time, enjoy yourself.